Welcome to another lesson of Math 0420 Introductory Algebra. In this video, we will be discussing section 5.6, dividing polynomials by binomials. In this section, we will divide polynomials by binomials. Dividing polynomials by binomials is a fairly straightforward task, but can be complicated if you don't practice it. So the first thing I want to do is I want to show you that dividing a polynomial is sort of like long division. So it may have been a while since you've done long division, but let's consider a number like 3,983, and we want to divide that by 26. And what you do is you see how many times will 26 go into this number. Well, we first start by looking at the first two digits. So how many times will 26 go into 39? Well, 26 will go into 39 one time, and so we'll subtract off 26. 39 minus 26 gives us 13. We'll bring down our 8. How many times will 26 go into 138? Well, it will go in 5 times, and so now we multiply 26 times 5. 26 times 5 is 130, so we subtract off 130, and we're left with 8, and then we bring down our 3. How many times will 26 go into 83? We'll go in 3 times, and then we do 26 times 3. 26 times 3 is 78, and so we can subtract 78 from 83, and that leaves us with 5. This last number is called our remainder. So if we were to rewrite this division as multiplication, well, first let's rewrite it in terms, 3983 divided by 26. Rewrite it as the quotient. That's 153. That's the part on top here. And the remainder is 5 out of 26. So rewriting its multiplication, we can rewrite it as 26 times 153 plus 5 is equal to 3,983. So in this case, 26, see if I can get an arrow to draw one more time. 26 is called our divisor. 153 is called our quotient. 5 is, as we said before, our remainder. And 3983 is our dividend. Okay, let's now try it when our divisor is in a number. So when a divisor is a binomial, here are our steps. The first thing is we will divide, then we will multiply, we'll subtract, and then we will bring down the next term, just like with long division. So example 1, we want to divide x squared plus 14x plus 45 by x plus 9. So we'll set it up in the same way as we would for the long division, being very careful to make sure that we have every power of x represented from the biggest to the smallest, and we have a 2, a 1, and a 0. And then our divisor is a binomial, which is x plus 9. And so what we do is we check to see how many times will our variable go into the first term. How many times will x go into x squared? Well, x times what is x squared? Well, it's x. Okay, so now what we need to do is we need to say x times x is x squared, and 9 times x is plus 9x. Okay, and then we subtract after we've multiplied. X squared minus x squared is 0x squared, and 14 minus 9x is 5x. We'll bring down our 45. And now we're back to the first step. How many times will x go into 5x? Well, x times what is 5x? Well, it's a positive 5. And now we're back to the multiplication step. X times 5 is 5x, and 9 times 5 is 45. And so we subtract those. 5x minus 5x is 0x. 45 minus 45 is 0. So in this case, we had a remainder of 0. So if we rewrite that as multiplication, we can rewrite x plus 9 times x plus 5 and say that that's equal to x squared plus 14x plus 45. So we had no remainder at all. Okay? That's how you do division of a polynomial by a binomial. Example 2. In this case, we want to divide 6x plus 8x squared minus 12 by 2x plus 3. So we want to write this as a division problem. I'm going to move down just a little bit. Note here that the 8x squared is not first. The 8x squared is actually the biggest power on the variable, but 6x came first. So we need to rewrite that inside the division as 8x squared plus 6x minus 12. And on the outside, we'll write 2x plus 3. So we start, as we did in the last example, how many times will 2x go into 8x squared? Well, it will go in 4x times, and we want to write that above the x term. In other words, over this term. And so when we multiply, 2x times 4x gives us 8x squared, and 3 times 4x gives us 12x. So we subtract. 8x squared minus 8x squared is 0x squared. 6x minus 12x gives us a negative 6x. We bring down our negative 12. Okay, and then we need to see how many times will 2x go into negative 6x, and it will go in a negative 3 times. And so negative 2x times negative 3 is negative 6x, and 3 times negative 3 is negative 9. And so when we subtract, negative 6x minus a negative 6x gives us 0x, and negative 12 minus a negative 9 gives us a positive 3. So our remainder this time is not 0. So if we were to rewrite this as multiplication, we would have to rewrite it as 2x plus 3 times 4x minus 3 plus our remainder over 2x plus 3. And that's exactly equal to 8x squared plus 6x minus 12. Example 3. This time we want to divide x cubed minus 1 by x minus 1. Okay, so inside our division. Again, we have x cubed minus 1, but remember, something I cautioned you about is that we have to have all powers of the variable included, or we will get off by a factor when we do the division. So we need plus 0x squared plus 0x minus 1. And then on the outside, we have x minus 1. How many times will x go into x cubed? Well, it will go in x squared. We'll go in x squared times x squared gives us x cubed. Negative 1 now times x squared gives us minus x squared. And we can subtract those. And we get x cubed minus x cubed is 0x cubed. 0x squared minus a negative x squared gives us a positive x squared. We bring down our next term, which is 0x. Okay, and how many times will x go into x squared? Well, x will go into x squared x times. And then now that we've divided, we now multiply. X times x is x squared. And negative 1 times x is minus x. Now we can subtract. X squared minus x squared is 0x squared. 0x minus a negative x gives us a positive x. Now we can bring down our negative 1. How many times will x go into x? Well, it will go in 1 time. So we have x times 1, which is x, and negative 1 times 1, which is negative 1. And we can subtract those. X minus x is 0x. Negative 1 minus a negative 1 is 0. So our remainder is 0, and we can rewrite this as x minus 1 times our quotient up here, x squared plus x plus 1, and that's equal to x cubed minus 1. And we'll see that this is called a difference of cubes at a later date in a different section, but this is how we can rewrite that difference of cubes after division. That is the conclusion of section 5.6, dividing polynomials by binomials. Good luck on your homework. Please let me know if you have any questions.